Hello everyone and welcome to my channel. Hope you all are doing well. In our previous video, we saw in detail what a finite automata is and what are the 5 characters it comprises of. So let's start with today's video, but before that, don't forget to subscribe to my channel and also watch this video till end and like the video if you learn anything from it. So in today's video, we'll try to understand the general model of finite automata, or you can say the basic model of finite automata, and we'll also see how it works. So let's quickly go through it. This is the finite automata model. As you can see, it contains 3 parts. First is the input tape, second we have the read head, and third is the finite control. Fine. Let's just see each of them one by one. Okay. So first we have the input tape. As you can see, the input tape here is divided into squares. These are the identical squares and each square is capable of holding one symbol each. Those symbols that are present in our input string. For example, we have an input string like 10101. So how are they placed in this input tape? First I'll draw an input tape with the identical squares. So now the symbols are placed like 1, 0, 1, 0 and 1. So this is the placement of the symbols. Here you can have empty blocks, empty squares available as well. Fine. So each square is capable of holding one symbol each. Now second one is this read head. This read head points towards the first identical square that is present in the input tape. What it does is that it reads a symbol from this tape, and after that processing is done by the finite control. The finite control is attached to this read head. Okay, the read head, or you can say the read head is attached to the finite control. Finite control read head reads the symbol and finite control processes it. After that it moves one step towards left and then reads another symbol. Then finite control again processes it and then it moves towards left again, then another symbol, then same way until it reaches the last symbol. Fine. One most important thing regarding the read head is that in this case it only moves in one direction, that is from left to right. It only moves in right direction, towards right, from this direction only. You can't expect if you, for example, let me take an example where you have a input string like this and the read head is present over here. You can't expect this read head to move in this direction, in backward direction. No. In this finite automata, in this type of finite automata rather, this case is not possible. So it only moves in one direction, that is this one. It only moves towards right. Okay, you have to keep this in mind. Fine. Then we have the finite control. What it does is that it keeps the traces of the states, or you can say the internal configurations. So let's take an example for this to understand it more clearly. Let's take an example over here and draw a finite automata, a transition. I'll draw a transition diagram for it. Let's say we have a diagram like A as an initial state and we have B as a final state, and let's draw the transition. Say at A we have 0. Let's keep B as our final state and draw the transition from A to B. Let's keep it 1. Let's draw it 1. Let's draw 1 over here and 0 over here. I'm just randomly drawing this finite transition diagram, so that I'll make you understand how it works. See, for example, we have an input string like 10101. Fine. So I'll place it like 10101. That is the placement that we discussed earlier. So this over here is the finite control. So how will it read the string? Fine. See, in finite control, as you know, it contains the traces of the states. So whenever the processing starts, I already told you that the processing starts from the initial state, right? So here the initial state is A. So the state present in finite control at the starting is the initial state, that is A. So okay, A is present, and then we have the strings like 1 0 1 0 1. See, at A, then it says at A it reads an input 1. See, at A, when it reads an input 1, it goes to state B. There is a change in the state of finite control. Now from A it moves to B. So here is a shift now. As I already told you, when once a string is read, it moves towards left. So now the finite the finite control and the read head is here. It's present in state B. Now at B, when it reads 0, it again shows a transition. We'll see it with the help of diagram. At B, over here at B, it reads, now this symbol is gone. Now it's at B, and it will read 0 as a symbol. So it will show a transition to state A. Now again, finite automata. In finite automata, there is a change in state from B to A. So once this is read, finite read head will move one step forward. So now the read head is over here. Again, here you have A, and then at A it reads symbol 1. So what will it do? It will change a state. You can see it from the diagram. When it reads 1, it goes to B. So there is a change in state from A to B, and now this is read. The read head will move forward, and now the read head is over here. At B, we have B in the finite control right now. So when B reads 0, when at B we have the input 0, it again moves to A. So there is a change in the state in finite control. Now the state is A, and 0 is read, so it moves one step left, and then we have 1. So at 1, we are at A, and it reads a symbol 1 again. It changes the state from A to B. See, you can have the string from here as well, but the string is empty, no symbol for the read head to read. So the processing stops, and we are finally at the state B. That is the final state. Okay, so this is how this finite control, the read head, this is how it works. See, now let me just make you understand one more thing over here, how a string is read. So how does it read a string? For example, I'll show you a method. In a cleaner method, rather. We are at A, okay. We'll write down the initial state, and then we'll write down the string that is that we have to read. 1 0 1 0 1 was the string, right? Here A is the initial state. The finite control is present in. Okay. Then you have to see that A reads 1. So when A reads 1, it goes to B. So 1 is read. You have to move this one over here. It means that it's read. Then you will place the state over here to which this A has shown transition to. For example, that is B, and then we have 0 1 0 1. Fine. Next, B will read. At B, when 0 is given as an input, to which state will it show the transition? So we'll write 1. It's read already. So this is the first one, this second one, then we have third one. This 1 is read already. You don't have to do anything with it. So 1 is read. Now B, at B, 0 is given as an input. So here at B, 0 is an input, so it will move to state A. So 0 is also read now. Now the state will come over here. The present state that we are in is A, and then we have the rest of the unread symbols. It's 1. Okay. Now let's take fourth one. Now at A we have the string symbol, input symbol 1. At A, input symbol 1 again goes to B. 1 and 0 are already read. Now this one is also gone, so it's read, and the change in state from A, and there is a change in state from A to B, and the unread symbols, that is 0 and 1, will be written here. Fine. Next step is B with 0. At B, when 0 is given as input, it goes to state A. Similarly, these three will come as it is, like 1 0 1, and again 0 is read, so 0, but there is a change from B to A, and then we have 1. Next, A reads 1. What will it do? When A reads 1, it goes to B. these 4 will come as such, and now 1 is also read, so 1 again, and then we have B. So you have to see this, just keep this thing in mind. I already told you, initially I told you that when the processing of input string is completed and we are at one of the final states, then we can say the string will be accepted. For example, at the end of the processing, if we had if we had the last string like this 10101, and at the end we had A as our state, where further no processing would be done. In this case, as you can see, A is not our final state. It's not our final state, right? So in this case, the string will be rejected. Now you understand how finite automata also reads the string. This is the way how the string is being read. Okay, I hope it is clear to you. Now let's move on to the next concept, that is the types of finite automata, or the types of finite automata or finite state machine. Fine. So it's broadly divided into 2 categories, that is FSM without output and finite state machine with output. So finite state machine without output is further divided into 3 subcategories, that is deterministic finite automata. This one is non-deterministic finite automata, and this is epsilon non-deterministic finite automata. Okay, and the finite state machine with output, there are 2 subtypes. One is Moore machine and the another one is Mealy machine. We'll go through each and every type and we'll understand it with the help of examples in our upcoming videos. We'll start with DFA and then we'll move on to NDFA, then epsilon NDFA, then we'll go to Moore and Mealy machine. Okay, so yeah, this was all for today. If you find this video helpful, hit the like button. In our next video, we'll start with the most important concept, that is how are we supposed to draw a transition diagram for a given particular problem. Okay, till then, take care of yourself and thanks for watching this video. Do like and share this video and subscribe to my channel and press the bell icon to remain updated. See you in the next video. Goodbye.